My history with Michael was nothing to do with research. It was about installation. I was a new LMC contractor about 35 years ago when I met Michael through Almirola at Dow. That was our supplier of our latex at the time. And he helped me get started and get through it. And over the years, he's been a big help. And also with CTS, going with VES LMC. So I'm going to do a presentation about a bridge that was done just outside of Pittsburgh, and just how it was done over a weekend. All right. First, what is VES LMC? Basically, it's the same mix design as regular latex modified concrete with a different cement in it. It's an ASTM C1600 cement. Same type of sandstone, fine aggregate, should be more than the coarse aggregate. Same number of latex yards or gallons per yard, about the same water cement ratio. And this you get strength of 2,500 PSI in 3 hours and about 3,500 in 24 hours. So really you only need about 3 hours of curing to open it. This particular job was done with a CSA cement, which is a calcium sulfoaluminate cement. It has little or no C3A in it, which increases sulfate resistance. Gains strength of 2,500 to 3,000 PSI in about an hour and a half, and has very, very low shrinkage. These are just a couple of charts of using CSA cement versus Portland cement, set times. Shrinkage. Shrinkage is very, very low with CSA cement concrete. Part of it is because the CSA uses more water than Portland. Portland needs about a 0.25 water cement ratio to hydrate. But because you have to work it, normally use about a 0.4 water cement ratio. So it's got that difference from 0.25 to 0.4 that bleeds off, and you lose volume in the wet concrete. So for this much, you lose over a cubic foot of water that doesn't hydrate. And the strength gain over time. And also the C3A is where sulfates attack. And CSA cement doesn't have any C3A in it. So it's totally resistant to sulfate attack. And this is a CSA cement versus a type 2 Portland cement after 6 years in a sulfate bath. CSA cement also has a lower carbon footprint than Portland cement, or even type 1L. This is the global warming potential. We have a EPD that shows these numbers for us. The Portland and the type 1 are just industry standards that were on the PCA website. Also, normally it's used a volumetric mixture. So this is just a picture for people that aren't used to seeing volumetric mixture. Basically, it's like a little portable batch plant. It's on a truck normally, but you see a sand bin, stone bin, cement bin. You have water tank with latex. You have a second latex tank. All drop down onto the belt. The belt goes down into the auger. That's where the liquids are added, and the auger mixes it. So you can start, stop as much as you want. Keeps everything good on the truck. Right, this is a Thornburg Bridge. It's a bridge just on the outskirts of Pittsburgh. It's Route 60 over a creek and a couple of roads and a railroad. It's a very busy road and a lot of pedestrian traffic. In fact, when they closed it down completely, just for the weekend, they had a shuttle bus carrying people around it, taking through the detours like you get from one side to the other. You always start a job with calibrating the volumetric mixers. So it's just a normal process of weighing material and going through making sure that the volumes are right coming out of the truck. They allowed the contractor to go in a little bit early on a Friday, close down one lane so they could begin their milling operation. Got a little jump on it, so they closed it, I think, about 2 o'clock on a Friday afternoon. And you can see, even with the beginning of the milling, you can see where some of the damaged areas on the bridge deck were going to be. This is getting into more of the full-blown milling and cleaning up. That's the big milling machine as it's finishing. See, very automated, dumping it right into trucks as they go. And then vacuuming, scooping right behind it to try to get up as much debris as they could. This is a little dark picture, but really just showing around the joints and stuff that had to be hand chopped to get it down to a reasonable level. And then the hydro demolition equipment came in. Now they're going to hydro demolish it. It's going to take another inch or so off, as well as any bad spots that are on the deck. And you can see right away how much debris is in front of it, that that's a particularly bad spot. And they wash it down, and again, you have to try to keep everything clean as you go, or else it will just dry out and become hard again. You see, it just pulverizes the concrete. But you can see in the front of the picture where actually down past the rebar, so we got more of that concrete. It's calibrated for the inch to take out, and if it hits anything worse than that, it'll take that out as well. So it's a total rehab as well as overload system. And you can see it almost white blasts the bars as well. No rust. Although this was an unusual job, that I saw some brown epoxy coated bars on it. So it made me shake my head to go over and look at it a little closer to make sure it wasn't rust. And then behind it to actually clean. Work from one end of the bridge to the other to wash it all down. And you're also impregnating the substrate concrete with water if you want a saturated surface drag. But you can see where all the bad spots are. And you can see where some old patching material remained that was stronger than the hydro, which means it's in still pretty good shape. So they put the overlay right over the top of that as well. Here's another cleaner picture of it. And you can see the rails are set on each side for the bridge deck finishing. They did that as they went along. And this is probably early Saturday. And it leaves a fantastic texture for bonding to. You don't really have to do any other surface prep. Where if you just mill it, you always need a second step of either shot blasting or hydroblasting, or old time was sandblasting. I don't think anybody really does that anymore. This is it, just about getting ready to pour. They wet it down and then cover it so that when the trucks are backing over it, they don't dump any grease or any contaminants onto the surface once it's clean and wet, and it tries to hold the moisture. Now they're bringing up the bridge deck finishing machine, and they'll be mounting it on the rail and then having a dry run through on it to try to make sure all their clearances are good. And put the right amount of material back. That's right at the beginning of the first joint. The Sprinkel was so wide they could bring up 2 volume mixers together and plate the concrete faster. They had 6 mixers on site. No, 8 mixers on site, 6 in constant motion, and then 2 in case anything broke down. This was we had one of our people came out with a drone to take some pictures, so just some interesting views of the thing. And you can see they roll back the poly as they move the trucks up. So they keep proceeding ahead. And the nice thing about using hydro is that you don't need to room in any grout ahead of time, or you can just go ahead and, once it's wet, just pour the concrete right on top. This was as it was starting to get dark on Saturday. Getting just a little vibratory action as it's coming out of the chute. This is the actual bridge deck finishing machine finishing it. It strikes it off, it rolls it out, it pans it off, giving it a little smooth surface, and then the burlap drag is the last step to give it a little burlap surface. If I can get this to work right, this just shows the motion of it. Details a little bit more. Then you got the pan and the burlap to finish it. This is just showing the work bridge behind the finishing machine to try to keep the curing on. Those are wet burlap that have been soaked overnight. They go on top of the concrete, and then on top of that is another layer of poly to hold all the moisture in. Again, just an overhead view of the same thing. And you can see all the reinforcing in the deck, so there's a lot of repair right here. A side view of it. They worked right through the night. They never stopped the replacement. I think they started about 3 or 4 o'clock on Saturday, and they ended up about 3 or 4 o'clock on Sunday morning. About 275 cubic yards. These were the strengths they gained. They were all 3-hour strengths taken as they went along to make sure that they're going to be okay opening and getting traffic on it. Well, actually, the beginning is they needed to get grinders on it, so they knew they had to have enough strength to put the grinders on it. This is the cure the next morning. This is now Sunday morning. Pulling the curing blankets off. The good thing is the majority of it's still wet, so they held the moisture in there. Now they're starting to grind. These are small grinders. Now I don't really know too much about the design of vertical grinding. I know it's supposed to reduce sound, but they needed to get it done before they could open this. So just 2 textures, one kind of along the barrier and one kind of out in the middle. And this was the big grinder. Cut those lines in it, which took a lot of the day on Sunday. One thing they couldn't get in was their line striper. So they just set up kind of a temporary so they could open it up, and they got just two. It's a 3-lane bridge. Temporarily, they just opened it up as a 2-lane bridge, one going each direction, and that lane in the middle they kept as a buffer zone between them. So this was opened by about 8 o'clock on Sunday night. One more. This is just a 1-minute little overview.